record. Okay, I don't know whether that's going to the cloud or my computer, but it doesn't matter. I'll figure that out later. Cool. So can you still see my screen?
Yes.
Yep. Nice. Yeah, so this is just a project update on KFData, which is an integration project we've been working on at Pachyderm in the Kubeflow community. This is the presentation I'll give in the community meeting tomorrow. And so I just wanted to start by recapping, like, what are we doing here? What's the goal of this project? Well, the goal is data-driven pipelines. I'm just going to move my camera slightly. Good practice for tomorrow. Point the camera at my face. So the goal here is, yeah, data-driven pipelines. So rather than the status quo with Kubeflow pipelines right now, is that it's very kind of pipeline oriented rather than data oriented. So pipelines will run whenever they're triggered, and they can either be triggered on a schedule, so they can run nightly, or they can just be run in an ad hoc way. And the pipeline doesn't really know anything about what data it's going to operate on. And there's no easy way right now with Kubeflow to trigger a pipeline when some new data is available. But that's a very common business process for a lot of companies, that they want to process data when it's available, or they want to build a machine learning model when there's a certain amount of new data that's accumulated or something like that. And so the goal of this KFData project is to enable data-driven pipelines in Kubeflow with incrementality in particular. And incrementality is really simple. It just means, like, when some data is added, you process that data, and later when more data is added, you only need to process that new data. You don't need to process everything. But actually, if you think about what I said at the beginning, with Kubeflow pipelines being quite pipeline oriented and not data oriented, that's actually quite hard to do, because if you're storing all your data in an S3 bucket or something, then it's hard to figure out, like, where, like, what data is new since last time I ran. That's a non-trivial question to answer. And so the goal here is to make it so that the Kubeflow and the pieces that we've integrated Kubeflow with can solve that problem for you, so you don't have to solve that problem yourself. So just to recap the design that I proposed in the original presentation here, the idea was, the initial idea was basically that you have this cascading series of types. And so you've got dataset types that define kind of a kind of storage, or maybe a particular instance of a Minio cluster or something, for example, that has maybe an S3 endpoint and an access key, but doesn't specify which bucket. And then you have a data set, which is a special instance, a specific instantiation of a data set type that maybe overrides the bucket field. And then the goal was that you could attach readers and writers to the pipelines, or that the pipelines themselves could request a list of readers and writer data sets, and that we would automatically track the lineage of which pipelines read from which data set and wrote to which other data set. Now, and then additionally, the goal was that pipeline runs would then inherit, like, these data sets from the pipeline spec, and additionally that a data system such as Pachyderm, which is able to drive this process of incrementality, in other words, it knows what data is new and what data hasn't been processed yet, is then able to additionally override specific pipeline runs with a given dataset spec, which might allow it to override, to really pin down and specify what's the new piece of data that I need to be processing. So that was the original design. And the update on the project is that we've got part of the way through it, which is fine. We have a piece which is useful on its own, but it doesn't have this dataset types concept in it yet. It just has this top level concept of datasets, but that's fine, that still works. And we're not yet tracking the readers and writers in the Kubeflow MLMD, the metadata database. That will be useful for lineage tracking, like I said, in the future, but we don't quite have that yet. So that's still on the roadmap. But we do have everything else here. So we have this new datasets type. We have pipelines being able to consume datasets, and we have pipeline runs that can be triggered with a kind of an override showing which piece of data needs to be processed to achieve incrementality. So here's a quick picture of what we built in a little bit more detail. So I kind of messed up this diagram because it goes backwards, so you need to start at the bottom right to see what's going on. But you get the idea. So the objects in the system are, there's Pachyderm, which is a system for data pipelines, effectively, that versions all the data and keeps track of lineage and so on. And we changed Pachyderm to support per datum virtual S3 buckets. And per datum is just a fancy way of saying incremental. So a datum in Pachyderm is the concept that allows Pachyderm to know whether it's processed some data yet or not. In this case, we're exposing a virtual S3 bucket per datum. So for each piece of data that shows up that needs to be processed, that makes it into a datum, which makes it into a virtual S3 bucket. Pachyderm exposes these virtual S3 buckets as Kubernetes services. So you can see here we've got the services actually showing up there in kubectl get services. Each virtual S3 bucket is scoped to just, you can see they've got these kind of auto-generated IDs, these services. They're scoped to just the new files that need processing for a given pipeline. And we're additionally now, which we weren't doing before, pushing those references to those data sets into Kubernetes datasets objects. And so every time Pachyderm is about to trigger a run, it creates one of these services with an S3 compatible endpoint behind it, but it also creates a dataset lifecycle framework dataset, which is then easy to attach to the actual pipeline job that's running. And so it's worth talking for a minute about the dataset lifecycle framework. So when we started this project, we thought that we were going to be implementing this dataset stuff ourselves, but fortunately, we discovered the dataset lifecycle framework from IBM. And huge thanks to Yanis from IBM, who's helped me a lot on this project. He's been very responsive on Slack, and we've had a call to talk about it. And yeah, they're excited that we're using their stuff, so it's a really good collaboration. And the datasets lifecycle framework has this abstraction that we were looking for of datasets in a way that's different to PVs and PVCs, because that's not really the right level of abstraction for what we're doing here. It also has this working admission controller, and we had this puzzle of, well, if you have datasets and you attach them to pipelines, then how does the actual user code in the pipeline know that it's running with a certain data set? And we were going to build an admission controller that injected environment variables in, so that the S3 client code in the worker could actually connect to the right place. And fortunately, the DLF had already done that for us. So that's awesome. So the first thing, just to go through this step by step, then Pachyderm exposes this virtual S3 bucket as a Kubernetes service. It publishes those S3 buckets into the dataset lifecycle framework. When new data is available, Pachyderm then also goes and triggers a Kubeflow pipeline run with a reference to that DLF dataset. That, remember that each dataset is scoped to just the new data that it needs to run on. And then the DLF admission controller intercepts the Argo pod that's created when Kubeflow Pipelines spins up the actual job, and it automatically annotates that pod with the environment variables that are needed. Or, and I haven't got this tested this piece yet, but it's also capable of mounting the buckets as files in the pod, which is awesome because then the user doesn't even need to think about reading and writing to and from object storage. So I'm excited about that. So yeah, just quickly, I'll show you a demo. So please pray to the demo gods for me. I only just got this working, but what we can see here is that we've got a Kubeflow instance that's running here at this URL, and if we go and look at the pipelines for the anonymous, which is just the default user, then there are no runs here yet. But this is a brand new cluster, completely fresh. But what it does also have is it has Kubeflow running on it with Istio and all that stuff. It's Kubeflow 1.1, which was quite hard work to get working, but I got it working. And then it also has Pachyderm running in here, and then it also has the dataset lifecycle framework stuff, which is the dataset operator. So yeah, Pachyderm and DLF are both running in the default namespace. So yeah, the first thing I'll do is I'm going to go into this directory here, and then I'm going to download some data. So I'm going to do a demo where I train an MNIST model using Keras. So it's like the most typical demo of a machine learning thing in the world. But what I'm going to show you as well is I'm going to use this command packctl to create a repo. A repo in Pachyderm is it's kind of like an S3 bucket, and everything in that bucket is versioned automatically, and it has all sorts of nice features like automatically deduping things. So I'm going to create a new repo, and then what I'm going to do is I'm just going to put that MNIST data, which is handwritten, is pictures of handwritten digits. I'm going to upload that into that new repo. So far so good. I'm then going to go ahead and create a pipeline. I'll show you what this pipeline looks like quickly. It's really simple. It just has a Docker image that has some Python code in it that has MNIST in it. And it also has these S3 flags set to true. And there's also one thing which is worth pointing out here. It's reading from the input repo. So it's going, whenever new data shows up in the input repo, it's automatically going to trigger pipelines. And it's also going to use a glob pattern of /star. And what that means is that it's going to kind of split the work up into files. So every new file that shows up is going to correspond to a new datum, which is a new unit of work, a new piece of work that needs to happen. By having the glob pattern of /star, it just means every single file corresponds to a separate piece of work. And you can do clever things like nesting your data in directories and then making each directory be a separate piece of work so that you can process things in batches. And Pachyderm allows you to commit things as well, which is nice. So that you can upload a bunch of files as a single atomic commit, and then that commit gets processed as a unit. So that is going to kind of define what work gets pushed into Kubeflow each time. So let's go ahead and deploy that pipeline. So we're just going to create that pipeline there, and then we can packctl this pipeline, and you can see that the pipeline has started. So remember, what's going on now is everything I just talked about. So Pachyderm's exposed this virtual S3 bucket as Kubernetes services, so we can go and see that. Sorry, they're not there, they're here. So that's the S3 service that corresponds to this specific execution using this specific piece of code. And then it's also going to publish a data set. So, oops. Those are in the anonymous namespace. And so we've got one data set for the input and a separate data set for the output. And that's interesting because Pachyderm has this model of you read data from one place and you write it to another place. And by having that separation between inputs and outputs, it's able to keep better track of provenance. And then let's see if this pipeline has finished. Okay, so it has finished. So if we go into the Kubeflow dashboard now, we can see that that run has happened. And I have to click around. There we go. I don't know why it wasn't showing all the green ticks. I guess I didn't have the right namespace selected and it was buggy. But yeah, so we can see this run just succeeded in 34 seconds. And there's this MNIST code that ran in here. And you can see there's a bunch of Python code that's running inside this pod. But the one thing I really want to point out is that the objects in the bucket are just that MNIST data that we put in first. Okay, so far that's not that interesting because we've only put that data in the bucket. And we can see that it then goes ahead and trains a model and then pushes that model into the out bucket. And then we can keep track of the provenance of that and so on. But the more interesting thing happens when we go ahead and, well, let's put some more data into the bucket. So I'm going to go ahead and download some different type of data and try and train this model on some clothes this time rather than some handwritten digits. And I'm going to put that data into the Pachyderm repo. And as soon as I put the data into the repo, that's going to trigger another run. And so this is where you can see it's gone from success to running because it now knows that Pachyderm knows that there's some more work to do. And this is really where the notion of data-driven comes in because new data showed up and it automatically went and created a new job in Kubeflow. And let's go and look at what data that job operated on. So if we look at the logs, so this is interesting, right? There's some code in the Python code is using the Boto3 S3 client to go and talk to what it thinks is an S3 bucket, but is actually Pachyderm. And Pachyderm has said, the only file for you to process is fashion_mnist.npz. But that's kind of where the magic comes in here, because if we go and look at the files in the repo, you can see that actually both of the files are there, which is important because you want to keep track of your data and you want to have that full version history and provenance of all of your data, but you only need to process the new data when new data shows up. And yeah, so that's really the demo. That's data-driven pipelines in Kubeflow. We triggered that pipeline automatically, and it was like we said in the introduction, it's not just about when to trigger the pipeline, but it's what data you need to do work on. So yeah, hopefully that's kind of proven the concept. And yeah, there's some stuff on the roadmap. There's some stuff that I'm hoping to do for tomorrow in time for the KFP meeting, like making the demo more realistic with a different example, trying out that mounting thing. There's a little bit of hard coding going on at the moment in the implementation. We're assuming that the data sets go into the anonymous namespace, but that's not quite right. So we need to figure out how to parameterize the namespaces. There's a large piece of work to do around productionizing and releasing the Pachyderm changes that we made to make this work. But it's worth noting we didn't need to change Kubeflow pipelines in order to get this working, so that's pretty good. And nothing that we did was specific to Argo. So when all of the IR stuff lands in in Kubeflow pipelines. The context there is Kubeflow pipelines are having a big change coming up about how they're implemented. This approach is going to carry on working in a post-IR world. Another big piece of roadmap is to save metadata about which data sets are consumed by which pipelines into the metadata store, which is really this piece. That'll be useful to answer questions like, how did my data get into this state? And then write some docs, do a blog post, and then we can promote how to achieve data-driven pipelines in Kubeflow. That's the demo. Questions?
Yeah, maybe this is sort of a naive question, but you were mentioning earlier on that this is obviously a pretty common use case, or something that you would imagine that a lot of companies would need. What is sort of the canonical approach right now to handling data-driven pipelines? Like, is like, if you were to go to the Kubeflow community, like how are companies currently doing this?
So what I hear a lot is that people are they're basically using nightly pipelines, and in some cases they're reprocessing all of their data every night because that's the easiest, like, first thing to implement. And that's okay at first, but then it gets really expensive.
Yeah, for sure.
Yeah.
No, it's pretty amazing. This is really cool stuff. But yeah, it's coming from a person who doesn't really have a ML background like that. That was sort of the first thing that came to mind. Is this seems like the first thing you would want to figure out? But no, this is really cool.
Yeah, no, it's interesting how, like, it is kind of a challenge that hasn't really been solved in the Kubeflow space yet, for sure.
Cool.
Any other questions or feedback, or like ways that I can make it better for tomorrow?
I mean, I personally thought it was really solid. I mean, again, coming from little background, I feel like I understood where this was going, and I don't know,
Okay.
good work.
Cool. All right, thanks. Kyle, anything from you?
Yeah, I was curious. Are you just using the existing Pachyderm functionality to trigger the Kubeflow pipelines, or is that that pipeline there? That's a Pachyderm pipeline, right? And then that sparks the Kubeflow pipeline?
It's the Pachyderm pipeline that triggers a Kubeflow pipeline.
Okay.
And I kind of intentionally didn't show the code because it's a bit of a mess. But I'll show you if you're interested. So yeah, there's this pipeline.yaml, which is this Kubeflow pipeline
Right. Yeah.
that's running this image that gets built every time I run the demo script, and the contents of the image is basically this Python script. And the Python script does a lot more stuff than it needs to do, so I can delete most of it, which will be good. But the main thing that it does here is...
Okay, yeah, that's actually what's connecting to Kubeflow. That makes sense.
So it's doing create run from pipeline func, which is, it's connecting to Kubeflow using the Kubeflow, the KFP client. So yeah, there's Pachyderm, which is running some Python code, which is starting a Kubeflow pipeline. Right. The interesting thing, though, is that the Kubeflow pipeline itself is also defined in the same Python file, because it uses this, like, Kubeflow's lightweight components thing, which is where you define a function that gets wrapped up, and then the function definition gets put in the spec of the pod.
Oh, wow, okay.
Yeah, which is kind of funky, and that's why you see these imports like inline inside the function definition.
Right.
But yeah, some of the work I just did today was, like, the dataset lifecycle framework puts the metadata about where to go and find the S3 bucket into the environment. And so we then go and find those bits in the environment to pull out the parameters, like where we go and talk to the input bucket and the output bucket and the S3 endpoint. And then we spin up the S3 client that's then pointing to that like special virtual thing. And then we do some training. And that's the bit where it prints out which objects are in the bucket.
Right. And that's what's actually running in Kubeflow.
Yeah.
So so then with DLF, you didn't need to do, or like, it sounds like then you didn't need to do the Kube Builder stuff. Like you just use their stuff, or did you also need to do your own CRDs as well?
Oh yeah, no, I didn't need to do any Kube Builder stuff.
Okay.
I didn't even
Sweet.
need to change either Kubeflow or DLF.
Cool.
Yeah.
Neat. So with this approach, would it be possible to use, like, to let Kubeflow, or sorry, to let Pachyderm run, and then like to have a, I guess a Kubeflow driven like pipeline? So you're basically only using Kubeflow objects, and then Pachyderm is just in the background as the sort of S3 giver and receiver. Or does that not make sense?
Is the question, can we like abstract away even the user needing to write this pipeline.yaml?
Yeah, like I'm wondering, like, rather than using like this is still very Pachyderm driven, which is totally fine and totally makes sense. But I'm curious, like, for people that are more used to being Kubeflow driven, if they can kind of plug this DLF plus Pachyderm thing into their existing stuff.
Definitely. I mean, I think Matthew's got some ideas on how to do that.
Okay, cool.
I think that when we had the first version, like frankly, when we had the first version of the Kubeflow Pachyderm integration, it felt a bit like doing it for the sake of doing it, and there wasn't really a strong kind of value prop, because it did feel like two pipeline systems kind of fighting for control.
Yeah.
But now that we've got the incrementality, there's a really strong reason to want to use the Pachyderm stuff, because it lets you drive the whole thing, and you can learn a little bit about glob patterns, and then you can be like, oh, holy shit, this thing's really useful. I just put new data in and it magically works. And so I see it feels a lot less to me like, it might just be because I've been working on it for ages, but it feels a lot less to me like they're kind of jostling for position now, because Pachyderm has this clear role of the thing that drives the data-driven like pipeline steps, and then Kubeflow is the thing that people presumably are already using to define their pipeline steps, and so they can carry on doing that. But yeah, it would be really nice if the user didn't have to like Docker build an image that has Kubeflow stuff in it and push that and then get Pachyderm to run that. I think that would be a really good next thing to simplify from the user's perspective.
No, I think that makes sense. Cool.
Awesome. Great.
No, it's great.
Wrap it up then. Thanks. Thanks for coming. I really appreciate you both showing
Thanks
up.
for the
Cool.
Thanks for the demo.
Yeah. Awesome.
Yeah, thanks for the demo, Luke.
See you in a bit.
All right. Cheers.
Take care, guys.